Now I'd like to welcome Kevin and Nicola to the stage.
Thanks, Mark.
Hey there. Thanks. So let's get straight into it. Who's sharing the screen? Okay, you're on it? Great. And talking about streaming APIs. Great. I'll leave you both to it. If we've got time for at the end for questions, we'll take questions, but I'm sure there's a lot of information to get through in the next 20 or so minutes. Okay, thanks a lot. Cheers.
Thanks. Thanks, and hi everyone. I'm Nicola Pietroluongo, and I'm here with Kevin Park. We are AWS Solutions Architect, passionate about technology and innovation. Today we are going to talk about streaming API, how to deliver data in real time, which is something that is becoming more and more relevant nowadays. Let's think about real-time analytics or event-driven architecture. This talk, you'll see what streaming APIs are, when to use it, and how to get started with them. I'm going to cover the API lifecycle and discuss most common API types, while Kevin will share with us the streaming API architecture and implementation, and we'll discuss also security and governance consideration. So let's get started with the API lifecycle. As you can see from the screen, those are the, let's say, 4 pillars of the API lifecycle: listen, learn, build, and measure. And of course, we believe that customers, so who consume your API, should be at the center of your API product. So you should release early and release often. This will allow you to learn fast, listening to your customers and metrics. And so with more data, you can identify more opportunities, improve the customer experience, and fuel the adoption. You can see how this cycle, this flywheel, will expand and grow over time. Of course, there are many different ways to build an API, and I'm going to recap the most common architectural styles before arriving to talk about streaming API. So let's start to REST API. And of course, REST API based on HTTP protocol. Probably I don't need to introduce REST API further, but again, it is stateless with standard HTTP methods, media type, also the support of hypermedia. But what's important for this talk is the client-server model. So the client makes a request, and the server provides a response. So this is the most important things that I'd like you to remember for this talk. Then next, we have WebSocket API. Based on WebSocket, and of course, WebSocket is a message-based transport communication protocol. So from a communication perspective, the main difference with REST API, of course, they are on different protocol, but from a communication perspective, WebSocket enables a bi-directional communication in a single TCP connection. So the initial handshake is performed only once. So we saw REST, we saw WebSocket, and finally we can arrive to streaming API. With streaming API, a single connection is opened between your application and the API, and new data is sent through that connection whenever available. This results in a low latency delivery mechanism that can support very high throughput. So another way, of course, for a server to push data to a client application is to use server stream events. And the main difference between server stream events and streaming API is that server stream events are browser-based API for establishing streaming connection in a standardized format. So it is used by the browser to receive data in real time. To recap a little bit what we saw right now, we saw REST, we saw, of course, WebSocket, bi-directional, so better suited in communication application like chat. Then we saw streaming API, single connection, used when you need to stream data as soon as it becomes available to an application. And also we saw server stream event, which are more suitable if you have a web page or a financial dashboard that needs to receive constant updates. Those are the main difference between those type of APIs. Let's see now an example of a communication flow of a streaming API. And you can see here a sample communication flow. The client makes a GET request towards an endpoint, and will receive the chunked response. This is an example of an ND-JSON response, which is a new line delimited JSON. So in Streaming API, you can expect additional messages as keep alive signal or other type of signal, and of course, new lines and returns between the JSON data. So your client, as you might notice, your client application needs to be able to cope with this type of format. Now I will hand over to Kevin to dive into architecture and also to see what we should consider when we build or consume a streaming API.
Thanks, Nicola. So first of all, let's have a look at some of the considerations that we would have when we're using a streaming API. So first of all, with the producer at the server side, in many cases, these considerations will be handled by the library or framework that you're using to implement server-side events or to use streaming APIs. First of all, as we would like to send multiple responses, it is necessary to send a keep alive signal from the client to stop the client from closing the connection. And we would use the response headers to send additional system information. So for example, sending a connection type as keep alive is assumed to be in place when we're using this sort of API. Another interesting aspect of streaming APIs is how we monitor them. So traditionally, we monitor REST APIs or digital APIs based on the number of requests that are made. And here we're actually more interested in the volume of the responses that we get for a particular request. So in the past, where you might have put limitations on tens of thousands of requests per day, now we're actually more interested in one request or dozens of requests with several hundred responses. We also might want to consider how we implement a replay mechanism. That's something we'll touch on in the next slide, but it's important for all of the clients to receive all of the updates and not just some of them or the ones that they were able to get in the time that they made the connection. For the client side, there are some more considerations to make. So the first of all is that you can't assume that the fields will arrive in a strict order. You might receive the different fragments of a response in fairly random orders. And so the client application should be configured in such a way that it will be able to handle those in any particular order. There could be missing fields from the information. So when you expect a fragment of data to come back, like a complete JSON, you might find that one particular field is missing. So in a financial application, when you're expecting to have the latest price of a particular asset come back to the client, you might find that the price is missing, but the other information is there. So your application must be resilient to missing information. As mentioned, they could be non-sorted. So they might always be in a strict JSON or tabular format. And we could also receive duplicate messages, depending on how the messages are being formatted on the client side, on the server side. One important thing to remember is also the failure scenarios. So what happens when we lose a connection with the server and when we try and reestablish that connection? What happens to those messages that we missed out in the meantime when we're reestablishing a regular connection? And that's why we mentioned the replay mechanism might be necessary for when new connections are created to give those users a few responses back from the previous session. So I want to have a quick look over the high-level architecture that we might expect in a high-level streaming API. So first of all, in data sources, we would have several different contributors to an API response. So previously mentioned, their response fragment could arrive in any order from one of these data sources. So it could be from a database, an application, or an event that's emitted by a third party. So various events emitted from data sources would be captured into a stream processor. And this is acting as an aggregator in the middle of our workflow. At this point in the streaming processing, we might expect some sort of form of extract, transform, or load, or ETL workflow to transform the message into a format that's more suitable for an API response. Open source products such as Apache Kafka and Apache Flink could be used to create a real-time streaming process. On the right of the diagram, we have the presentation where the client makes a request to a stream response via an API and through an authentication service. And the API gateway passes the response back from the API server. So this part is a little bit more of a traditional concept that you would be more familiar with, where a client making access to an API server via an API gateway. The API gateway will be responsible for the governance and authentication. And that still exists in this model as well. The only difference being that when a connection is opened, it is kept open, and then continuous responses are sent back through this stream process workflow. Also in this diagram, we can add in this idea of the replay cache, which I mentioned before. And this would allow new connections to receive the past few seconds of responses before they start to receive live updates. And this mechanism can help avoid the client being missing responses when they're reestablishing connections. So this is a very high-level view of how this might look in your architecture, and it does follow some of the event-driven and serverless concept that have been mentioned in previous sessions as well. And here are a couple of example implementations of streaming APIs for you to take a look at in more detail. So the first is a fairly common use case that you may have seen or used before, which is the Twitter streaming API. And this provides access to a stream of tweets and interactions that have been made available by Twitter. And it basically returns a continuous stream of JSON objects to represent all of those different interactions. And then you can use that to build out a real-time view for the consumer of all those different interactions going on, without having to constantly re-establish connections to the Twitter API. There's also a helpful open source implementation in Go, which is available in GitHub. And this provides both the client and server code for implementing server-side events, which is the more common approach to the browser-based API that Nicola mentioned earlier. Further to this, Ruby on Rails has a built-in class for writing events from the server as well. So I'd encourage you to have a look at these if you're not familiar with server-side events, or if you're not familiar with streaming APIs, one-way streaming APIs. These would be some good places to start looking into if you were looking to set something up. So we mentioned as also one of the big parts we want to go into detail here is about security and governance. Now, this is quite important that a lot of the security is pretty much the same as a standard REST API. The client can use existing key or token when they're requesting or establishing a connection with the API server or API gateway, and they will continue to authenticate in the same way. So if you're already using API keys, or if you're using some other key and secret, or if you're using a token through OAuth or some sort of Java Web Token, then you can continue to use that. The same established connection will continue to work. So there's no special security requirements that we need to consider for streaming APIs. However, you may want to consider how you rate limit or throttle the connections, as now a single request can have multiple responses. And what may be worth asking yourself is the cost you have of maintaining an API associated with serving a request from the connection, establishing connection, or is the cost associated with building the response and providing that egress out from the server to the client? In a lot of cases, you might find that the additional cost, or the cost to you as an API provider, actually comes from how the number of responses you give and not the number of requests you get. Previously, you treated everything as a one-to-one. Every request gets a single response, but now you're getting one single request with multiple responses. So you have to consider that when you look at rate limiting and when you look at how you can manage volume requests to your API. One small side note on terms of security is you may want to consider ways that you can close connections if you find that the connections are no longer needed, or if they're being used outside of your terms of service. Then you might want to have some sort of mechanism for dropping a connection whilst it's still receiving updates. But outside of that, it would be very much similar to your existing REST API. So finally, just a couple of conclusions and last points on this slide. So taking us back to the very start of the presentation, Nicola spoke about the flywheel, where we continuously iterate and improve on our API to improve the customer experience and develop new opportunities in order to grow your API product. So streaming APIs can be an extension of an existing API without the need to change the main underlying protocol or governance that you have. These may be worth considering if you have a large number of single resource requests. So if you have a lot of use cases where particular clients or applications are continuously polling your resources, looking for updates for to give that sort of more rich experience to their end users, then this would be a better approach to consider something stream APIs. It's the way you can avoid the customer from simulating real-time updates, but actually giving them real-time updates. So what you should do is allow these customers to establish a streaming API connection, and then they can receive a continuous stream of updates without repeatedly creating connections. And as we've seen in the architecture diagram we showed earlier, is that although there is a fairly large change in terms of the back end, in terms of how you might be generating this information by building a stream processing and pushing that forward through an ETL workflow and into an API server, there wouldn't be too much difference from the client side, and allows you to make a small iterative change to your API in order to keep it up to date and in order to keep it fitting for what the customer needs are. So thank you very much for your time today. I hope this is useful. Nicola and I will try and answer some questions if there's some time available, and if there's anything that you want to bring up particularly. Otherwise, thank you very much.
Thank you both. Great to have you here, and thanks for the discussion and walking us through, both from the life cycle point of view and then also as it relates to streaming APIs in particular. So when an organization is thinking through this, what's the sort of typical use case that you see them first seeking to do this with? I imagine that it's going to be a gradual approach, to build up that expertise.
It is. I mean, back to the kind of flywheel that we shared earlier, it's kind of a trial and try to succeed approach. Of course, maybe from the beginning, it's not clear which type of API or API type, or even which type of protocol our kind of API product would use. But streaming APIs are best suited when we need to share data. So anything about financial services, again, real-time notifications, or anything related to the data, and it's good use to consider streaming API. We know that this is going to be a growing area as well, because again, we have more data. We want to do real-time decision. We want to do real-time analytics. We want to act upon signals as soon as they enter in our systems. So we really believe this will be will have more attention in the future as well.
How mature or how ready are organizations with their data sets, let alone them moving it into the streaming? Like, is there seems to be, in order to be able to start streaming and acting on data in real time, you also need to have your data clean to a certain level, at least have a data model and those sorts of ideas. How much are you seeing as people go to implement streaming API type architectures that they like, hang on a second, we need to get our data sets in order first?
Yeah, I'll let probably Kevin then add more on this topic since he was sharing the architecture as well. To be totally honest, if you think about a streaming API, the data set and the data response could be, so the data payload is basically not so different than a normal API. So in terms of data, it's probably, so data schema, that's what I'm trying to say. Data schema is probably not the biggest problem. The biggest problem is to try to build the pipeline and so build up the architectural best practices to support the streaming scenario. I'll let Kevin to add more on that.
Yes, so one thing we did look at a while ago in preparation of this was how this actually converts from a typical monolithic API or monolithic architecture, where you might not expect to have a lot of live updates, or at least they would be live updates, but they'd be going into a big central database, a big transactional database, and you wouldn't have you exposed to those events that come out. But what we might find is more and more applications are moving over to microservices and to small backends that are more agile, then we're able to pick up more events from different data sources, and those will be those fragments that we mentioned before, where you'll be able to use smaller partial updates from say database inserts, or they might be events that come from other microservices. Those you start to find that you have more and more of those in your architecture, and then you'll be able to build out these as opportunities or offerings to your end customers. But likewise, you might be able to see from customer usage that if there's a lot of people that really want to see like their live data, like their a stock value going up, for example, then it might be a case of working backwards as we say, well, where's that information come from? How do we make that live? How do we start to build that into a streaming process?
And then some of the use cases are for the benefit of the end customer, but might not even be visible to the end customer. So things like fraud, fraud analysis of a new transaction or something like that. How do you? So then, are you seeing? So then, how does that work with the flywheel that you described, where you're talking about the end customer and involving them in identifying the value out of it? When it's those sorts of things that almost the customer takes for granted that is happening in the system or isn't aware of those sorts of things, how do they get surfaced in that sort of model?
Yeah, I mean, the one of the things that we wanted to discuss was again feedback mechanism. Before even building a product, you as builders, you need to have a strong feedback mechanism, which means also release APIs in preview, so API that might not be production ready, because as soon as we're getting this feedback from the customers about the type of features that they want to maybe to see, soon we can act upon that. Of course, then there are the other part that also Kevin mentioned, the metrics. Metrics and analysis and data, it's the key to drive conversation and additional and discover also additional opportunities as please the customer in different ways. One thing that I like to add to, again, the kind of things that you correctly say they are for granted, like I don't know, financial in financial maybe services or even fraud detection are kind of for granted. But what we're seeing as a shift area nowadays is actually what also Kevin was touching earlier. There are a lot of different systems now that are providing data. The concept of omni-channel experience that we're carrying on for years. So we have really a lot of different data that are providing. So a lot of different systems that are providing different data points. So to have an aggregated view might require really a strong consideration of streaming API or streaming services.
Right. That sort of the 360 view, the sort of that complete view of what's happening, because the data is coming from so many disparate sources. Okay, that's fantastic. Do you want to share your contact details, or how will people follow up with with you both or learn more?
We're gonna stay in the chat for a while, and we're gonna also grab a few questions there and share our kind of accounts and social media account as well.
Okay, wonderful. Thank you. Because we don't have any questions. There is a slight lag, I think, on my computer for the stage questions, but we're not seeing any there. But I'll invite you now to leave the stage so that we can welcome our next speakers.
Thanks.
Thanks for that.